Hi, welcome back. On today's lecture series, we are going to discuss about the construction of single phase transformer. So, just this is a quick recall about the last class. The electromagnetic induction is the working principle of a single phase transformer, and this is mainly it is based on the mutual induction between the primary winding and the secondary winding. And based on the mutual induction between the primary and secondary, the voltage will be induced in the secondary winding, and that will be connected with the load. And based on the load requirement, we can able to adjust the number of turns in the secondary. So that's called an voltage transformation. That is, we can able to increase the voltage or decrease the voltage based on the number of turns. And the energy transfer between the primary and the secondary with the minimal losses. Almost we are expecting the 95% to 99%. And this is a quick recall about the last class. And today we are going to focus on the core material which are used for the construction of single phase transformer, and the winding arrangement, and the insulation system, and what about the tank and cooling. So why it is more requirement, why it is more important, that is to increase the energy efficiency and to minimize, so that the losses can be minimized. And the thermal management, it is nothing but the heat management can be easily management. And how long it is going to work, that is the reliability in service can be most important. So we are going to use this design thinking approach to this topic. So first, while empathizing the construction of single phase transformer, so according to the user need, so why this transformer reliability should be very high. High reliability is required for what? Why high reliability is required? And what about the maintenance requirement? Whether it's the maintenance you are expecting the minimum maintenance, or it may be maximum maintenance, and how long it will work on, that is nothing but the lifespan, how you are expecting. So these are according to the power utility. And the industrial users, they will consider the voltage regulation, and how the overload capacity is acting, and how about the compactness. So these are the users in the kind of industrial user side. And the designer will think on how the cost effective materials can be minimized. So with the minimum cost, how we can able to design effectively, so that how to increase the efficiency standard, and how to improve the safety maintenance. So these are the designer aspects. And in the second stage of define, so based on the user empathy, so we have to set some define, we have to find out what is the exact problem. So here the main problem, the magnetic core losses in a transformer, it consists of two losses. One is hysteresis and eddy current losses. So because of this eddy current and hysteresis losses, the efficiency can be reduced, and also because of this indirectly it reducing the energy wastage. Sorry, it increases the energy wastage. So and heat generation is also high, and the performance is very lower. Also, here the copper losses, that is nothing but invariable losses. It is mainly with respect to the current. So that will appear in the single phase transformer. So if the copper loss is getting high, the efficiency also gets reduced, and heat generation is also high, so that it affect the insulation breakdown. So if the heat is produced in the system, the winding insulation maybe gets breakdown. And so that in order to avoid the heat produced inside the transformer, so we have to handle the heat accumulation system, because otherwise the premature aging and the reliability also can be reduced. So these are the challenges we are faced in the single phase transformer. And in the third stage, ideate. So here the construction of single phase transformer, normally it has two types of construction. One is core type transformer, another one is shell type transformer. So here in this core type transformer, it has two limb. So this is an one limb, and this is a second limb. So here in the first limb, the primary winding is connected, and the second limb, the secondary winding will be connected. Here the primary winding is connected with the source, and the secondary winding is connected with load. And in the shell type transformer, it has three limbs, and both the primary and secondary winding is mounted on the center limb. Okay, so in the core type transformer, it has only one magnetic path, but in the shell type transformer, it has two magnetic path. Okay, so here The core type windings surround the core limb. The winding will surround the core limb, and in shell type, the core surrounds the winding. The core will be surrounds the winding. Okay, so the core type or shell type, it is based on the voltage rating. If you are in need of a low power system or high power system, so based on the voltage rating, we can choose any core type or shell type. So normally the core type, the transformer core is made up of silicon steel, so that it produces the low permeability, so that the flux linkage is very high. And the laminations of the transformer core approximately 0.35 mm to 0.5 mm thickness. So it is mainly to reduce the eddy current losses by the laminations. And okay, so here the two winding, so one is called primary and one is called secondary. So the both the winding is made up of copper. So if it is made up of copper, the cost is high. But even though because of the copper, the efficiency is very high, and the copper, it produces low heat. The heat generation is very low, efficiency is high, and it is high reliability. So that instead of aluminum, we are always choosing the copper. Okay, and it is also very easy to cool. And next, in the insulation system, so here mainly we are using the paper insulation. We are using the paper insulation between the windings to insulate for the insulation. And the transformer oil can be used. So here the transformer oil, it is in the dielectric strength of 30 to 50 kilovolt per so based on that, we can able to transformer. For it is also I can use it for the insulation as well as cooling. Paper is only used for insulation, and the oil can be used as an insulation as well as cooling purposes. And batteries and cylinders also can be used. Here also we can maintain the insulation systems. And the tank and cooling method. So here it may be an forced system or it may be a natural system. So based on that, either oil natural or air natural, or it may be forced oil, or it may be a forced air system. So by using any of this system, we can use to cooling the transformers. And this is the manufacturing and the quality validation. Here the core can be assembled in the transformer core, and the primary winding and secondary winding will be tested, and it will be wound on the transformer core. Again the tank will be assembled with the oil filling and the perfect sealing, again with the help of testing ratio test, polarity test, insulation test, open circuit test, short circuit, everything will be tested. And finally we are dispatching the system. So this testing and load test, everything is comes under testing part. And this is the real world application. It can be mainly the transformer which are used in the mobile phone adapter, laptop adapter, and as well as power transformer to step up the voltage or step down the voltage, and also for welding furnaces. So these are the several applications in the real world applications. And this is the mind map. So have we seen about the magnetic core? It is made up of silicon steel, and it has two winding, primary and secondary. The insulation can be paper, oil, or some other system can be used, and the transformer oil can be filled with the oil. And this is an cooling. It may be the natural cooling, or it may be forced cooling of oil, or or it may be an air. And the accessories like bushing, conservator can be needed. So these are the transformer according to the constructions. And this is an curiosity challenge. Why our transformer core is laminated instead of using solid steel block? Okay, so this is mainly to reduce the hysteresis and eddy current losses. Mainly the why it is laminated means it is to minimize the eddy current losses in the system. Can we use aluminum winding instead of copper? Yeah, we can use, but the aluminum has 61% conductivity of copper. So here the aluminum is lightweight and its cost is cheaper, but the losses is very high. So instead of aluminum, we are always preparing the copper in the high voltage sector, because it gives good reliability and good efficiency also. The power losses also can be minimized. And this is an assessment question. Compare core type and shell type transformer construction which is prepared for high voltage applications, and why. So you can put your answer in the comment section. If you are these are the few reference books and some of the online resource materials. Thank you.